Hey there, curious listeners. Get ready for a deep dive into the dynamic and often dizzying world of cloud computing.
It really can be.
Yeah, we've sifted through a stack of material, everything from head-to-head comparisons of the major cloud platforms to specialized solutions for, monitoring and storage,
Hmm,
all to get you clued in fast.
that's right. Our mission today is really to cut through the noise. We want to distill the core differences between the biggest players in the cloud, unpack how businesses actually manage and secure these, well, vast environments,
Yeah.
and then look at some innovative ways data gets stored and accessed. You'll walk away with a much clearer picture of this essential technology landscape, and hopefully a few genuine aha moments about how it all fits together.
We've pulled insights from comprehensive overviews of the major cloud providers,
Yeah.
detailed product information, and articles on cloud infrastructure. So what exactly are we exploring today? Let's unpack this. When we talk about cloud computing, three names inevitably dominate the conversation: Amazon Web Services, or AWS, Microsoft Azure, and Google Cloud Platform, GCP.
The big three.
Exactly. What's really fascinating here is how each has sort of carved out a distinct identity, even while offering, similar foundational services.
Absolutely. AWS, which really pioneered the commercial cloud when it became public back in 2006,
Right, the first mover.
it's still the largest provider. It's known for its incredibly extensive range of scalable solutions, from foundational storage to complex networking. Just massive.
Okay.
Azure, following in 2010, really excels with its scalable software solutions, especially for those large enterprises already deeply invested in Microsoft products like Office 365. Makes sense,
Yeah.
right? Integration.
Total sense. Leverage the existing ecosystem.
Precisely. And GCP, which launched App Engine in 2008 before expanding into its full platform, well, it truly shines in high-end big data analytics, machine learning, and AI tools.
The data and AI focus.
Yeah, alongside robust support for cloud-native applications like containers, they're really strong there too.
It's interesting how their origins influence their trajectories. AWS had that crucial head start, didn't it?
Oh, absolutely. That certainly helped it build out its vast service catalog and gain an extensive user base and reputation early on.
So, stepping back,
Hmm.
their geographic reach is huge too, right? The source material mentioned regions, data centers.
Massive. And this global footprint enables, well, more than just speed. AWS, for example, is divided into 22 geographic regions, 14 data centers, plus over 114 edge locations.
Wow.
Azure operates in 54 regions, each with at least 3 availability zones and 116 edge locations. GCP has 34 cloud regions, 103 zones, and over 200 edge locations.
So many locations.
And for you, this global distribution means data can be deployed not just closer to end users for faster access, that's the obvious bit,
Yeah.
but it's also crucial for meeting data residency regulations in different countries, data sovereignty, and for building truly resilient, geographically distributed applications that can withstand regional outages. It's about reliability, too.
Right, right. Okay, let's talk about the actual computing power, the virtual machines, the core compute, yeah.
Yeah.
All three offer services for renting virtual computers in the cloud. AWS has EC2, Azure has virtual machines and scale sets, and GCP provides Google Compute Engine. Different names, similar idea.
Pretty much. But they also go beyond just raw machines. They each have their own platform as a service, or pay us.
Right, pay us. That's where you deploy code without managing servers.
Exactly. You focus on your application. Plus, they all offer robust container services, think Docker and Kubernetes. Like AWS's Elastic Container Service and Kubernetes Service, Azure Kubernetes Service, and Google Kubernetes Engine, GKE.
Kubernetes is everywhere now.
It really is. And of course, serverless functions such as AWS Lambda, Azure Functions, and Google Cloud Functions, where your code just runs, without you ever thinking about a server. Event-driven stuff.
Super efficient for certain tasks.
Definitely. This also brings up the crucial topic of how they handle storage. And it isn't as simple as just files.
No, I bet not.
AWS provides flexible storage, including Simple Storage Service, or S3, which is, well, it's kind of the standard for object storage.
S3, yeah. Heard that a lot.
Think of it as storing massive amounts of unstructured data, like videos or backups. Azure uses various options, including page blobs for VM-based volumes and square blobs for object storage, similar to S3.
Okay.
GCP offers both transient storage and persistent disks, along with Google Cloud Storage for object storage.
So different names, but similar capabilities.
Similar core concepts, yeah. The main thing for you is that they offer a range of storage types optimized for different needs, whether it's high-performance disk for a database or cheap, scalable storage for, say, a data lake.
Right, matching the storage to the job.
Precisely.
And here's where it really gets compelling, I think. Their focus on AI and machine learning.
Oh, yeah. Big battleground.
We found that Google Cloud is often highlighted as a front-runner in AI advancement, largely crediting its development of TensorFlow.
That's a big one. TensorFlow being open source helped a lot.
But AWS isn't far behind with tools like Gluon and SageMaker, and Azure has its powerful cognitive services, things like Bing Web Search and Face API integrated.
Exactly. So while Google might have that sort of open source AI pedigree, all three are pouring huge resources into making AI accessible for businesses. It's not just for tech giants anymore.
Good point.
What's also important to note from the material is their approach to hybrid and multi-cloud environments.
Connecting the public cloud to your own data center.
Exactly. Or even connecting multiple public clouds. This allows organizations to combine public clouds with their existing on-premises infrastructure. AWS offers things like Snowball for data transfer and Outposts for running AWS services on-prem.
Okay.
Azure features Azure Arc for managing resources anywhere, and Azure Stack for running Azure services on-prem. And GCP provides Anthos, which is designed for managing applications across hybrid and multi-cloud setups.
So flexibility is key. They know not everyone can go all in on public cloud immediately.
Definitely not. It's a popular strategy for many organizations who, can't just lift and shift everything overnight, or maybe they don't want to.
Makes sense. Now, for the bottom line, and often the biggest question for businesses, pricing.
Always tricky.
All three use competitive pay-as-you-go models. Right?
Yes, pay for what you use. Generally.
Our research indicates that for let's say a basic instance, 2 virtual CPUs, 8 gigs of RAM GCP can be around 25% lower cost than AWS.
Can be, yeah.
Approximately $52 per month compared to AWS at $69 and Azure at $70.
Those are specific examples, of course.
Of course. And for the really large instances, the costs and specs vary wildly. Azure's largest instance costing around $6.79 per hour, AWS is around $3.97 per hour, and GCP's largest around $5.32 per hour.
See, it flips depending on the scale and type, plus you have reserved instances, spot instances. It gets complex fast.
So it's not just the sticker price.
Absolutely not. The ultimate cost depends heavily on usage patterns, data transfer fees, which can bite you, and the specific mix of services you use. You really have to model your workload.
Good advice.
Ultimately, choosing a platform isn't about picking a winner. It's about understanding your specific business needs and technical requirements.
Right.
Each provider has unique strengths, making them a better fit for different types of workloads or existing IT ecosystems. For you, understanding these distinctions is absolutely key to making informed strategic technology decisions.
Okay, so once you've navigated that cloud platform choice, or maybe, like many, you're using a mix of them, a multi-cloud approach.
Very common.
How do you actually monitor and manage such incredibly complex environments? It seems daunting.
It definitely can be. This is where a solution like Datadog comes in. Our material dives into Datadog's focus on Google Cloud Platform monitoring specifically, but it's important to know it's part of a much broader unified platform. It works across clouds.
Unified monitoring. That sounds useful.
What's truly transformative about Datadog, I think, is its ability to unify monitoring across an entire cloud environment, not just one silo. It collects and analyzes metrics from over 35 major Google Cloud services alone. GKE, BigQuery, Cloud Functions.
Wow, 35.
Yeah, and that's just GCP. Plus AWS, Azure, on-prem stuff. And you can often start monitoring in minutes with auto-discovery. It just finds your resources. Then you visualize performance with customizable drag-and-drop dashboards.
So like a single pane of glass for everything.
That's the goal. It's like having one intelligent dashboard for everything happening in your cloud or clouds.
And beyond just seeing what's happening, Datadog really digs into cloud costs, right? Which can, spiral out of control if you're not careful.
Oh, tell me about it. Cloud bills can be terrifying. Yes, Datadog offers granular cost breakdowns, letting you allocate expenses to specific dimensions like product, service, or even individual teams using custom tags.
Tagging is crucial there.
Absolutely. You can even drill down into resource-level costs within Kubernetes, right down to the individual pod level.
That granular. Wow. I remember working on a project where cloud costs were like a black hole. Nobody knew where the money was going. Tools like this sound like a game changer.
They really are, because this granularity is crucial not just for understanding, but for optimizing cloud spend, and also for resolving performance issues faster.
How does it help with that?
Well, Datadog helps reduce your mean time to detect, or MTTD,
Hmm.
and mean time to resolve, MTTR.
Finding and fixing problems faster.
Exactly. How quickly you spot something's wrong and how quickly you fix it. It automates root cause analyses across applications and infrastructure. It lets you investigate issues across front end, back end, and infrastructure layers with like a single click.
Connecting the dots automatically?
Yeah, providing end-to-end application tracing and real user monitoring. So you see the users click all the way down to the database query, for instance.
That sounds incredibly powerful for troubleshooting.
It is. And for those heavily invested in containers, you mentioned Kubernetes, Datadog provides complete visibility into GKE environments, pulling in metrics, traces, and logs from Google Cloud, Kubernetes, and Docker, all correlated.
So full container visibility.
Yep. You can even optimize horizontal auto-scaling the HPA by connecting Datadog to it and collecting metrics like request rate and latency, making sure your applications scale efficiently, not just wildly.
Smart scaling.
But Datadog isn't just a data collector, it also brings intelligence to the forefront. What's particularly powerful is their use of AI and machine learning within the platform.
Ah, AI for monitoring.
Exactly. It helps ensure optimal performance with alerts powered by machine learning. It automatically detects unanticipated outliers, anomalies, and errors with a feature called Watchdog.
Watchdog. Okay.
It proactively prevents outages by alerting on metric forecasts like, hey, this trend looks bad, or specific data thresholds, and it even leverages AI to account for daily, weekly, and seasonal fluctuations to eliminate those frustrating false positive alerts.
Oh, that's huge.
Yeah.
Alert fatigue is real.
It really is. Getting paged at 3 a.m. for something that happens every Tuesday. No thanks.
Haha. Yeah. So Datadog essentially acts as your central nervous system for the cloud.
That's a good way to put it. Pulling all these threads together across infrastructure, applications, logs, security, digital experience, software delivery, service management, and even AI model monitoring.
It covers a lot of ground.
It gives you that single, intelligent view of your entire operation,
Yeah.
ensuring you're not just reacting to problems, but proactively preventing them.
Okay, so that covers monitoring and management. But when you're managing all this complexity, with vast amounts of data flowing through these platforms, being monitored,
What about the sheer volume of data itself, the storage aspect?
right? Data keeps growing exponentially.
That brings us to storage, specifically iDrive E2. Our source material positions it as an Amazon S3 compatible cloud object storage solution that really stands out with its focus on, well, affordability and robust security. Yeah, iDrive E2 is making some waves. What's genuinely surprising, or at least headline grabbing, is their claim to be 90% cheaper than AWS S3.
90%, that's significant.
It is. But it's not just the low base cost per terabyte. A huge factor is they boast no fees for egress, that's data going out, or for API call.
Oh, egress fees, the hidden cost.
Exactly. Anyone managing cloud bills knows egress can significantly inflate your storage costs, sometimes more than the storage itself. So zero egress is a big deal.
How affordable are we talking?
You can actually get started with 10 gigabyte free just to try it out. And it's priced at an incredibly accessible $24.75 for the first year for 1 terabyte. Or $5 per month per TB for Veeam users, which is a specific backup integration.
Wow, okay, that is aggressive pricing. But what about security and reliability? Cheap isn't good if you lose your data.
Absolutely critical points. The material highlights 11.9's data durability.
11.9, so 99 point, lots of 9% durability.
Exactly. It means an extremely low chance of data loss. Statistically, like 1 in a quadrillion chance per year or something like that. Industry standard for high-end object storage.
Okay, that's reassuring.
It also protects against ransomware with immutable storage via object lock.
Immutable storage, meaning
Meaning, once data is written using that policy, it literally cannot be changed or deleted, even by administrators, for a set period. It provides an ironclad defense against ransomware encrypting or deleting your backups.
that's smart, a ransomware defense.
Very smart. Plus, it offers bucket versioning to retain previous object versions. So if you accidentally overwrite or delete something, you can roll back. Standard S3 feature, but essential.
Good safety net.
And it emphasizes compliance. SOC2, GDPR, HIPAA. Data is stored in centers with physical and biometric security. Transfers use TLS encryption, and data is encrypted at rest. Standard security practices, but good to see them highlighted.
So the security and durability seem solid. What about access and performance?
Right. For you, this translates into flexibility and reliability. iDrive E2 operates across 13 locations currently in the US, Canada, Europe, and Asia.
Global presence, too.
Yeah, allowing you to deploy data closer to your end users for faster, lower latency access, or to meet data residency requirements like we discussed with the big clouds.
Makes sense. Other features.
It offers things like cloud object replication for redundancy across regions, event notifications for real-time alerts when files are added or modified useful for automation, and detailed bucket logging for security auditing.
Okay, pretty comprehensive feature set for object storage.
It aims to be fully S3 compatible, so it needs those features.
And the compatible clients list looked impressively expensive.
It really is.
Yeah.
Because it's S3 compatible, it works with a huge range of existing tools and services built for AWS S3 for disaster recovery, media workflows, data archiving.
Give us some examples.
Sure. It integrates seamlessly with Veeam for backups, which we mentioned, Adobe Premiere Pro for media projects storing large video files affordably, Snowflake for feeding data lakes, cPanel for website backups. Even common desktop tools like CyberDuck and FileZilla Pro can connect directly to manage your storage.
So wide integration. You probably don't need to change your tools if you switch.
That's a major selling point. Reduce friction. Beyond just raw storage, iDrive E2 supports a myriad of use cases. Infrastructure as a service, IaaS components, data backup and archival for entire systems, servers, VMs.
Use cases seem broad.
Yeah, imagine managing petabytes of media files without changing your workflow, or storing massive data sets for your AML projects more affordably, or even securing video surveillance data offsite.
That surveillance data adds up fast.
It really does. Oh, and they also offer free cloud data migration from other providers like S3 or Azure Blob. That removes another barrier to switching.
Free migration is a nice perk.
Definitely lowers the activation energy. And managing it all seems straightforward with their web console. Centralized view of storage, create and manage buckets, user management with access permissions, account settings. Standard stuff, but looks clean.
And it even does application backups.
Yeah, interestingly, it also provides automated daily backups for popular cloud applications like Microsoft Office 365, Google Workspace, Dropbox, and Box, which is slightly different from object storage but adds versatility to their offering.
So it's kind of a storage platform plus some backup services.
Seems like it. Blurring the lines a bit, maybe.
Okay, so
Yeah.
let's try and tie this all together. What does all of this mean for you, the listener?
Yeah, let's connect the dots.
We've seen the sheer scale and specialization of the major cloud providers, AWS, Azure, and Google Cloud. Each has its own strengths, right?
Yeah.
General scalability, enterprise integration, or cutting-edge AI.
Yep, different flavors.
Then we explored how services like Datadog provide that critical unified monitoring, keeping an eye on everything, managing costs proactively, using AI to get smarter insights across these really complex cloud environments.
Bringing order to the chaos, essentially.
And finally, iDrive E2 showcased an innovative approach to object storage, focusing on affordability, especially that zero egress plus solid security and incredibly broad compatibility because it speaks S3.
A specialized player challenging the giants on price and specific features.
So looking at the larger ecosystem, you can really see how these distinct yet interconnected services form the backbone of modern digital infrastructure. It's not just one thing, it's layers.
Absolutely. And understanding these specialized roles and how they integrate is crucial. Whether you're, managing an entire enterprise cloud strategy or just exploring new ways to store your personal project data more effectively.
It applies at different scales.
Definitely. And the growth in cloud computing jobs really reflects this. Salaries for developers, architects, security folks in this space often exceed $100,000 annually. It underscores the increasing demand for professionals who can navigate and leverage this intricate landscape. This stuff is important.
This deep dive has definitely highlighted the incredible diversity and constant innovation in the cloud space. It's evolving so fast.
Constantly.
It seems clear that the future of computing isn't just about picking one monolithic platform, is it?
Not anymore, generally.
It's more about strategically combining specialized tools and services to meet truly unique needs, building a cloud environment that's just right for you.
Tailoring your stack. As cloud environments continue to grow in complexity and scale, and they will with AI and machine learning becoming more integrated into every layer.
AI.
Everywhere. The need for intelligent, unified visibility, sharp cost control, and robust, compliant storage solutions like the ones we discussed, that need will only intensify.
Which raises, I think, an important question for you to consider as we wrap up. As these cloud giants and the specialized providers continue to evolve and compete, Will we see further consolidation of services? Maybe fewer major players eventually swallowing up the innovators?
Or the opposite.
Or, yeah, will the future bring an even greater proliferation of highly specialized tools, each tackling a very specific niche problem? More fragmentation, maybe.
Interesting question. Consolidation versus specialization.
How will that ongoing race for market share shape the simplicity or the complexity of managing your digital world in the years to come?
Yeah, will it get easier or harder to piece together the right solutions?
Something to mull over until our next deep dive.